Welcome to problem 9.15, B and C. These problems come from section 9.2, nuclear equations in your book. It asks you to write a balanced nuclear equation for the beta decay of each of the following radioactive isotopes. And so for B, our radioactive isotope is oxygen. I'm going to draw that here. So we're given we know that 8 is our atomic number, which is the identity of oxygen on the periodic table. And then 20 is the mass number, so the number of protons plus the neutrons for this specific isotope. Okay, and so we have decay, so we know we're going to be writing our reaction arrow there. And it's beta decay. So the main thing that you have to know here is you have to know all of your particles, your radioactive particles. So beta is written as, so that it kind of looks like an electron, or you see it written like so. Okay, and so if we have beta to K, that means we're going to be producing a beta particle plus an isotope. Okay, and so our balance has to be balanced. Our numbers have to be balanced on each side. So if we add up all of our atomic numbers, on the left side, it has to equal the atomic numbers on the right side, and the same for the mass numbers. Okay, so here we have a total of 20 and 8. Okay, and so we have to determine what our numbers are going to be here, and then based upon the atomic number, we can figure out what the element is. Okay, and so let's first just do the mass number. So we have a total of 20 on the left-hand side, and then we have a 0. So 20 plus 0 equals 20, which equals 20 over here. So we have 20 and 20. Okay. Next, we have to find what element or what number is going to equal 8. So we have a negative 1. This means we're going to have 9 minus 1 equals 8. And so if you look on the periodic table, you will find that fluorine has the atomic number of 9. And so that's how you know what element or what isotope is being produced. So just to clarify here, this is what your answer should look like. Okay, same idea for strontium-92. Okay, 92 is the mass number. Okay, so it's the number that goes up top, or the superscript. So if we look up strontium, like so. And if you find strontium on the periodic table, you will see that its atomic number is 38. Okay, and we also have beta decay. We're trying to find what isotope is going to be produced. Okay, so once again, we have 0, so we know that 92, we have 92 on this side, 92 plus 0 equals 92. Our numbers have to be balanced, or have to be the same. Okay, and so we know that our atomic number is going to have to be 39, because 39 minus 1 equals 38. We have 38 as atomic number, and 38 as our atomic number there as well. And so if we go and we find 39, we find that our element symbol is Y. Okay, now I'm going to show you how to input one of these into mastering, because I think some of the problem is actually, for students, is actually just inputting it correctly in the mastering system. I'm in mastering now, and so we're going to enter the correct answer. So if you look at, we're going to do 9.15C. Okay, and so what we do first is we go to our toolbar, and we're going to go to the far left button, and we're going to choose the third stacked super subscript. Okay, and we're going to enter in 92, and then we're going to click, use your cursor and go down and click to put in 38, the atomic number of strontium. And then we're just going to click right beside it, and you should see the large cursor come back. We're going to write in our symbol. Then we're going to go to the second symbols on our toolbar and pick our reaction arrow. It already spaces it, so we're set up for our next particle that we're going to enter. And so we're going to go back and get our stacked super subscript. We're going to put 0 for our beta particle and -1. Then we're going to click next to it again. When we see that large cursor, we're going to put our E. And then we don't even have to space it. You can go ahead and just push add a plus. Okay. And no space again, you don't have to put that in. It's understood once it's a reaction, it will separate the two. And then we go back to our stacked super subscript, and we place in 92 and 39. Press next to it, click Y, and we should enter the correct answer. I hope this helps with problem 9.1.